Hi, this is Mr. Beck does your homework. This is homework number 12 on Springs and Hooke's law. This is question number 6. It reads, Janet wants to find the spring constant of a given spring, so she hangs the spring vertically and attaches a 0.37 kilogram mass to the spring's other end. The acceleration of gravity is 9.81 meters per second squared. If the spring stretches 2.5 centimeters from its equilibrium position, what is the spring constant? Answer in units of newtons per meter. So here what we have is we have the ceiling, or she's hanging it vertically, so we'll just say we attach it to the ceiling. And so we have an initial spring, and then when the spring has a mass attached to it, the spring is going to be somewhat stretched. The reason the spring is stretched is because there is a force of gravity down on the spring, and therefore the spring is responding with a spring force in the opposite direction with equal and opposite force to the force of gravity. And then the spring stretches by a certain amount, and that amount we call x. So let's see what values we have. We have a 0.37 kilogram mass. That's m equals 0.37 kilograms. So a 0.37 kilogram mass. If I want the force of gravity, that is going to be the mass times the gravitational constant, the acceleration of gravity. So they give us that g, the acceleration of gravity, is 9.81 meters per second squared. What that means is that the force of gravity is going to be mg. And so for me, that's going to be 0.37 times 9.81, and that's kilograms times meters per second squared. So that will give me a force of gravity that's going to be so many newtons once you plug it into the calculator. Now, that's the force of gravity. That is going to equal the spring force, so that is also the force in the spring. Now, the other value we have is that the spring stretches 2.5 centimeters, but we want to answer in newtons per meter. So we're going to have to convert centimeters to meters. So 2.5 centimeters times, we know that there are 100 centimeters in 1 meter. So that would give me 0.025 meters is the x. Now we want the spring constant, and the spring constant, we know that the force in the spring is the spring constant times the amount the spring is stretched. Therefore, the spring constant is going to be the force in the spring divided by the amount the spring is stretched. So we're going to take the newtons we had here for the force in the spring and put it up top. And then the distance that I had, for me, it was 0.025 meters. We place that in the denominator. And then you will get K in the units of newtons per meter. So that's going to be newtons on the top and meters on the bottom. So that will give you a value for your spring constant in newtons per meter. And that is question number 6.